Hi, I'm Brad Leeds, and I'm with the AVT team here at the AVT Vision Center. I'm going to show you the Argus system with a SpectroLab, or spectrophotometer, and the ease of use when you use our offline setup. With our offline setup utility, we have 4 simple clicks in order to tell the machine what to do during a production run. The first thing I do is I tell it I want to set up a new job. We give this job a name that's been predetermined and an ID code to indicate what is this job when you run it today versus when you run it again in the future. For these 3 clicks, I just simply press the check mark. Now everything is being loaded to the system from our offline server. We've already set up the PDF document, any kind of spectral measurements, any kind of area tasks with our camera, with UV lighting, things like that. Take note, currently the machine isn't running. While we're loading this information, it can be done while the press is down, while it's during the changeover for the next job. And it was 4 simple clicks, got everything we needed loaded into the system. Now that everything's loaded up, I'm going to start up the press. Now that we have the press up and running, make sure we're happy with what's printing. And I have to click just one button telling it to run. Everything else is being automatically done behind the scenes. We've already told the system what the image looks like by loading a PDF document. We've already given limitations for the cameras, telling it where it needs to look on this material. And everything's lining up, setting up. The master image is currently aligning. While this is happening, you can see our viewer on our other side is running as well. We're able to move around and take a look at other areas of the web before the job's even started, or before the job's finishes setup. Our spectral measurement unit is now moved into place to start taking spectral measurements. Take a look at what's happening then in this bottom right corner. I click here and we can see our preloaded colors. We have halftones, we have our full density colors, our substrate we're printing on. Currently the unit's moving back and forth, taking measurements of this. The more important part is here at the bottom we can see the system's inspecting. It's looking at the material with our 100% camera, determining what is the difference between what's currently printing and the master image that we captured at the very beginning of the run. While it's still currently inspecting, we're also doing a quick comparison of this master image crossed with a PDF to make sure that everything's correct, that we don't have a plate loaded incorrectly or any kind of misregistration that could be bad material. So our system's moving, it's inspecting. This is the AVT unit in action. What just happened now is our master verification is completed, so we can view the report. This report is showing what are the differences between the PDF and the master golden image that we captured at the beginning of the run. Looking in here, we can see our master image. In this area here, we have our PDF image. We can easily toggle between the two to see any kind of differences. And if it's a large repeat like this one, we can zoom in and try and find these differences and determine if we need to capture a new master to make sure our print is good, or if we can continue with the run of the job. As an example, I've loaded a PDF that had some defects built into it. Here, when I toggle between, I can see that we have a misprint, 10 grams versus 100 grams, or some more vital information over here on the left side. I have a misprint as well in our ingredients bar. Once again, you can see a change in the ingredients percentages. Now when I simply hit the finish button, the system prompts if we want to save a report of this. We'll say yes. This creates a PDF report that's going to show the master image that we captured, the PDF image that we're comparing off of, and it's going to show an image of every defect, every misregistration that we found in that job. Take a look again over at our spectral measurements. We can now see that we have some readings where we can see our LAD values, target versus what they currently are, what our delta E is with that. We can compare that on our graph. We can also look at the density of this particular value based on how I loaded it earlier. Density changes. Once it's captured its main 100% values, it now goes and starts reading on the halftones because I told it to check on the halftone measurements. You can see here in our cyan, once again our LED graph, delta graph, the density measurements, and our tone value versus what we had originally told it should be to what it is now. While it's gathering this information, we can see our area cameras moving around as well. Right now it's showing measurements of barcodes. We're getting grading values. Additionally, this camera can be used as a viewer to view UV varnished material and your front to back registration. By simply changing my light source with 2 clicks, I told the system we're now in a UV light, and I've preset up some what we call fast keys that tell the camera where to go and look for particular areas in the material. So I know I had some UV ink in this area, we're telling it how to move around and quickly move around between these different areas with a single click of a button. Now while I'm running, back here on our main screen, we have our inspection button. We can tell it to start and stop throughout the run. Zoom in, change brightness. I have a quick toggle between defects and what the master image is, so we can easily compare and see what this defect is. And then even if the defect is of great concern, I can tell the area camera up top to move to that particular position so we can get a better look at what's going on. Change my light source back. You can see that particular area and the defect that it's used. This is the AVT system. This is our Argus with a SpectraLab measurement unit. Everything's been preset up offline. Next, I want to show you what all the steps were that went in to make this happen in 4 clicks. I want to show you a couple of other features about the machine. We talked about roll reports and how we can assign a barcode, we can load these reports on a downstream system. Let's take a look at these reports from this end. These reports are built for every job that's ran. Basically based on job name, the order, and the rolls that are actually made during that order. When we see these, we're able to look at the history of what ran on the machine and information about that particular job. And I can see several aspects of the job I ran before. Actually, that's our current job. Let's look at the job I ran before. Here we can see statistics about how much of the material was good, bad, how much was not inspected. Information about the defects we found, what kind of defects did we find? Spots, streaks, color issues, things like that. Now it's on touchscreen. Really have the data, timestamps of when it started, when each roll finished. You can see our job rep report showing us the PDF image, the master image we captured, and the individual little defects we found in that comparison. We also have an option called the Event Viewer. The Event Viewer will show the span of the whole run, what the operators did at the screen. Whether they changed the sensitivities, what they did when the screen, what the screen looked like when the job was set up. See that here? What the sensitivities were set at, and any time that the roll finished. It's a full time lapse of that particular order and what the screenshots were whenever the operator clicked on it. Additionally, we have our spectral lab measurements. Our LAD values based on all the points that I had selected and set up prior. What these measurements were. Density measurements of this as well, all points or each individual color. The dot gain halftones, what measurements we got. And then our barcode grading throughout the run with our area camera moving around. All this information on this print flow reports, while it's accessible here at the station itself of the Argus, it can also be installed on a laptop or a workstation, and it can be accessible by anyone. All they need to do is have access to the same network that the Argus system is on, and all this information can be seen. All this information can be exported as well. The Spectral Lab information can be sent out in various file formats. The job ref information can be, it's a PDF, you can send it anywhere, and things like that. Now our system's down here running. One thing I didn't get to cover very much earlier, I forgot to, was how easy our system runs on sensitivities. While when we compare an image, a new image to the master, we have different things we call sensitivities to determine what we show the operators as what's good and what's bad. First, I can see here our register. This is a registration tolerance, which gives a tolerance of how sensitive the system's going to be as a whole for 100%. We have our spot, streaks, color, others, and edges. Now with all these other ones, we determine a defect based on how large is it and what's the contrast change from the master. So we just simply have two different bar graphs on a 10-point scale to determine what defects we should find and shouldn't based on their size and their contrast. Contrast can be a difficult thing to determine, so one thing we've done is whenever we do find a defect, I can actually right-click on the defect itself, and it'll show me what is the size of it and what is the contrast, so that I can better set these sensitivities up here at the top to shutter out any noise or any false positives that may happen. Along the bottom of the screen, we are seeing all the defects gathering. As they gather like this, they start going away, but that's what builds our report with the red lines and the blue lines that we ran our workflow with on earlier. I think that's covered all the things about the AVT Argus system with SpectraLab. Thank you. And here I'm going to show you the offline setup process. These were all the steps that were done that made the job so easy for the press operator to get it up and running. In the top right corner, I have setting up a new job. I simply just need to give this job a name, however you guys identify it at your site. Here I'm going to tell it the material type. If you're printing on paper, we can have this stuff locked in. And I'm going to tell it a couple tasks to do. I want to tell it a unique point, to do a job verification. All the options I want the operator to not have to worry about, I can set up right here on the screen, and we can determine what options are shown based on these tasks to run on the right hand side. I need to tell it some information about the job. How large is the repeat? What's the circumference? And how many rows and lanes do you have of packages? Now I need to load the PDF. Since we're going to do spectral measurements, we want to know where these color bars are located in the full repeat. So I'm going to load a PDF of the entire repeat, but we could also we could do this off of loading just a single package, and it will array all the settings across all the packages. When I tell the system it's a repeat, and simply hit next. Part of the way our system works is we give it boundaries of where the camera needs to inspect, and this is what I'm doing right here on the repeat, or on the PDF. Since the PDF is a true PDF with the proper dimensions of the package, the camera is going to know what areas to look at. So we have the width of the package determined by the green lines I just set, and then the height that we see here is based on the circumference that I set earlier in the job. I just simply want to try and center things up and hit next. Now here I'm going to select what we call a unique point. This is the ability for the system to recenter any image issues if any colors or any issues were to happen on press. We're simply telling the system this is a locking point, that whenever we capture full repeat images, how to line things up so we can detect defects properly. Now I'm going to load in my spectral measurements. Since this system has already been configured with our spectrophotometer, we have a lot of standard codes or standard colors already loaded in the system. I'll load in some full colors and some half tones. Select these different options. Here we can see all this data populated based on our color bank. When I look at the properties of them, as I click on each color, it's already been set what the LAB, what any kind of values, target densities, things like that should be based on what we've already imported from your existing color system. I'm going to tell it targeting options such as for the dot gain, what reference to use. For this particular system, I'm going to load what we call a substrate. This is how we can cross-reference and get proper values for your LAB and other spectral values. Now, since I loaded the full repeat, I have a color bar in here. I'm going to zoom in nice and close so I can take a look at the colors. And I'm going to select my points. My 100% cyan. 40%, and so forth through all the colors. Now while I'm manually going through and selecting these on this, we do have the ability to import an actual color bar. If the color bar is fixed amongst all your jobs, we can store this in the system. And when you load in this color bar, it'll automatically, you just highlight the area where the color bar is, and it automatically associates these points within the bar itself. And what their values, what you want to call the colors, all of that is automated. We just don't have that here in the shop. Lastly, I select my substrate for my cross-reference, and we're done. All of our spectral data has been loaded. Now I'm going to tell it some cover tasks. We're going to tell the area camera what to do. In this particular case, I'm going to tell it to just do some barcode verifications. I'm going to tell it to scan all the barcodes that it finds in the job, in the repeat, and set standards for how I want to read those. Now, one of the key features we talked about earlier was what I called fast keys. This is my ability to highlight an area of the repeat and assign it a fast key. Our system supports 5 fast keys. So I'm going to just highlight over our areas with the UV ink additive. And this is just creating the steps so that when the press operators are running, if there is a troubled area of the print, they can quickly refer to these areas while they're running to get a look and see how the job is printing. Here we can tell it the sensitivities. Now the way our systems work is based on sensitivities of size and contrast. So when we look at the different sensitivities such as register, spots, streaks, we can assign values to these for each job. So if one customer is more particular than another, we can have higher sensitivities or so forth to make sure that you produce good product for your customer. Same thing with the area camera. When it's going around grading barcodes or if it's inspecting the surface of the material, we can assign the sensitivities for that as well. Now when you get more complex packages, while I loaded a full repeat of the PDF, sometimes I want to go into more detail on just a package and have it array to all the other packages. So with our package selection tool, I can highlight just one of the packages and the array of them. And I can assign things like character sensitivity to inspect text at a higher scrutiny. Go ahead and try that. Masking is the ability to tell the system to completely ignore part of the package. So if you have a die cut area that is uniform across the packages, we could tell it to ignore that area. And then lastly, we have what we call regions of interest. This is the ability to tell the system to pay more attention to one area of the package than the rest, or vice versa. So if you have a particular area of print that needs to be scrutinized different than the rest of the whole package of print, we can assign that area, such as ingredients down here. We can tell it that here we want to make sure that our characters is much more sensitive than the rest of the job. Or I can make another one, and I can say that the registration at the barcode is much more important. So I'll highlight this area and set my registration tolerance higher than the rest of the job. Once I click next, we've now set up a job completely on the offline setup system. All the tasks I just completed would normally be done by a press operator while they're out at the press. But since I've used the offline, everything's done here, and now the press operator has 4 clicks to load everything I just did here, and then their job starts running.
Action.
What I want to show you next is our workflow link solution. This is the ability that when a roll is completed on the press side, we apply a barcode, we automatically scan this barcode, and as it goes downstream, we load this roll data onto a separate piece of software, and we can control what happens with it. I'm going to demonstrate how with this roll data we're able to see defects within the roll itself. We can tell the system basically anything. We use relays that can be activated before and during a defect, and we can tell this particular rewinder system to stop on these defects at a certain point, or we can activate a light, we can activate any kind of inkjet, marking equipment, things like that. So I have my job synced up. We're looking at a number 2, which is visible over here right now, and when I start to run the machine, as it runs through, I can see 2 arrows start to meet. We automatically slow down this machine and we tell it to stop. Now, this one was really close. We'll run a little further on the next one. But what's happened is we know based on the footage, the amount of repeats, where these defective packages are. And we're able to stop or control the machine or interact with some other kind of device to notify the operators where these bad packages are at. Let's do another one. Do this at higher speeds. Speed isn't an issue. But we can see we have a green line indicating where I want to be notified and a red arrow indicating where that next defective image is, defective package is. We get a visual interpretation showing what is that defective package or defect in the package, and right next to it is what it should look like. We have some simple buttons on the screen, such as a toggle button that will let us toggle between what is this defect and what should it look like, so you can determine if it needs to be removed or not. This is our workflow link solution. What we proposed was a fully automated loading of these barcodes of these jobs, and synchronization so that any kind of bad material can be marked and removed from your downstream process of the press.